In this presentation, we will be discussing the ANOVA and Chi-Squared tests, the differences between the two, and how to use the SAS/JUMP software to perform both tests. Comparing the ANOVA and Chi-Squared tests. One should use the ANOVA test when determining if there is a difference between groups. This is an analysis of variance. The data is categorical and continuous, and there are more than two groups. A chi-squared test is used to show the relationships between categorical variables, and this is a test of independence. The data consists of observed and expected values. The null hypothesis is always that there is no relationship between variables, which means that they are independent. For the ANOVA test, we perform an F-test using the F distribution. There are no units because we are looking at the correlation between variables, and correlation is dimensionless. R squared is the coefficient of determination to explain variance. If R squared is high, there is a strong correlation between variables. Otherwise, there is not enough evidence to support that there is correlation between the variables being tested. The chi-squared test uses the chi-squared distribution. Degrees of freedom are determined by taking the sample size n and subtracting 1, and the degrees of freedom are used to find p using the chi-squared table. P is the probability of being consistent with the null hypothesis, and if P is greater than 5%, there is not enough evidence to reject the null. There are three types of ANOVA tests. ANOVA is one-way, and there is one independent variable. ANOVA 2 is two-way, and there are two independent variables. ANOVA is multiple analysis of variance. This is a test for the difference between means, and there are multiple dependent variables.
After importing the data for a chi-square test into JUMP, we must first make sure that both sets of categories are in nominal. Then we will go to fit y by x and select gender and put it into the x and cookie choice into the y. As you can see, male and female have been split up onto the right and left side, and the cookie choice of each of the data points is also seen on the right side. In this case, we are able to determine that we can accept the null hypothesis that there is no difference between male and female in their cookie choices due to the fact that the probability is 0.5873. For the ANOVA test, our data set represents 25 men and 25 women who rated cookies on a continuous scale from 1 to 10. In this case, it is important to ensure that the cookie ratings is a continuous data. Now we will select fit y by x and put the cookie rating as the y-axis and gender as the x. Being that the probability is only 0.0519, there is not enough evidence to reject the null hypothesis.